Length of arc and area of sector. In this video, we will focus on sector areas. You will find this on page 510 in the Namibian Ordinary Level Mathematics textbook, Y equals mx plus c to success. Sector areas. Investigation. This investigation, you can just press on this QR or this link and you can have a look at the investigation. But I will only look at the conclusion. So let's just move it up. So from this investigation, we see that area of sector over area of circle equals sector angle over 360. They represent the same fraction of the circle. Note, we complete the formula by making area of sector the subject of the formula. So just like we did with arc length, now it's just going to be the angle over 360, not multiply the circumference, but multiply the area of a circle. And how do I work out the area of a circle? Pi r squared, and then I will get that area. Okay, let's look at an example. Find the area of the sector OCPD of the circle with radius 8 centimeters, giving the sector angle as 135. Now, in this case, you can take pi as 3,142. I'm actually telling you to take it now as 3,142. So, but you can also use the value of pi on your calculator. So it's just this over 360 multiply, there's the pi, there's the 8 squared, so it means 8 times 8, and there is my final answer. Okay, again, I want you to do number A, and I think I'm going to give you D again. You can continue the video as soon as you are finished. Stop first the video. Okay, let's start. If I look at this one, so find the area of sector OCPD, that green area, in each of the following diagrams if the radius is 10. So don't forget, the radius is 10. Okay, same there. In all the examples. So if I'm going to start there is number A. So I'm going to say area of sector, and that's going to be OCPD, and that's going to be, now that remember that's 90 over 360 or a quarter, multiply, and now I should have, yes, let's just do it like that. If I said in this, it was the angle over 360, just want to clean that again, over 360 multiply pi r squared. So it will be this multiply pi multiply r is 10 squared. And if I press that on my calculator, I will get an answer of 78.5 centimeter squared. Just want to check it quickly. 360 multiply pi multiply 10 multiply 10, and that's 78.5. Okay, and then number D. So in this case, I'm not looking for this, I'm looking for this. So this was 360 minus 60, and that will be 300. So again, I can now just start with the formula. So the area of sector OCPD, and that is going to be 300 over 360 multiply by, and now it's going to be 10 squared, exactly as the previous one. Okay, but it's just this part that's different. The final answer to 3 significant figures will be 262 centimeter square. Okay, let's move on to another example. Did I now skip 2? I just want to see. No, it was correct. I will skip back. Okay. Just waiting for it to move. Okay, let's start with number. Now I was wondering if I was skipping now too many. 18, yes, that's correct. In the diagram, OMPN is the sector of the circle with center O and radius 8. The area of the sector, now they give you the area, and you must find the angle. Now, how do I do that? I just take the formula, I just substitute, and I just make x the subject of the formula. And I press this on the calculator. That will be multiply, that will be divide, and I get correct to 1 decimal place. Now, the area of the segment MPN. MPN. Now, I must first work out the area of this one. Now, how do I think of non-90-degree triangles? Chapter 9, it's half 8 times 8 sin. Can you remember? The area of a triangle that's not having 90. And then I just basically going to subtract it. Okay, let's again look at another example. Okay, I want you to stop the video and I want you to do number 2. You can continue the video as soon as you are finished. Okay, so let's start. Number 2. In the figure, O is the center of the circle of radius 6 centimeters. The area of the sector OQPR, so it's this whole one, is 35 centimeters square. Okay, now first find the angle. Okay, so it's exactly like, and you can even check here, that one. So if I'm going to start, I'm going to say, okay, let's rather put it here on top. And I'm going to say the area of OQPR, no, let's make it P, R is equal to the angle, let's call it X, over 360, multiply the area of the circle. So if I substitute that, so I'm telling you that area, that's going to be 35. I have the angle, now I'm looking for the angle. And the area is pi, and the radius, in this case, let's see, is 6. So to find that x, I will multiply the 360 on this side. Otherwise, you can just work it out first and then divide the total. And this going to 6 times 6 is going to be 36 pi. And if I press that on my calculator, I will get 111.4 degrees. Okay, so end again by the question. Remember, this was A. So therefore, angle QOR is 111.4 degrees. And then number B, the area of the minor segment, QPR, that one. So I will first work out the area of this. Remember, I'm having the angle now. What is that angle? 111.4. So if I work out triangle, so first calculate, so triangle or ROQ. ROQ will be area triangle ROQ is going to be half. Now this is going to be the sin, but I'm just going to use it now. Sin, so it's going to be the non-90 degree triangle. So that's why I say sin, because you use sin here, not cos. Sin of that 111.4. And if I'm going to now calculate it, I'm going to get 16.8 centimeter square. Now I just want to quickly press it on the calculator because this is a middle step. So no, 0 times 6 times 6 times sin 111.4 equals. Okay, it's actually, because it's an in-between step, I want to show you, it's better, it's a bit big. It's better to keep it 16.7590046.9. First keep it unapproximated. You can use, because this was the end of A, you can use that one. But this is in a section, so I keep the unapproximated value. And then the area of the minor segment, so QPR. So now, I just want to see here the area of the minor, area of the segment. It's that one. Okay. So therefore the area QPR, Q segment QPR is then, okay, what was it in that previous one? It's the 35 minus that 16.7590046.9, and that will give you an answer of, I just want to check, 18.2 centimeter square, and that's correct to 3 significant figures, and that's how you do it. Okay, let's look at the last one in this example in this video. In the diagram, these are sectors, okay, this one and this one. Center O. PQ is C6, that one. OP is R, okay. Angle is 120. If the area of the shaded, I'm telling you the area of the shaded, find the value of R, okay. Now, the shaded part is the area of the big sector, this big sector minus the area of this sector. Then I will come to the shaded part. So if I'm going to look, it's 120 pi. Now remember, I just want to show you here, PQ. It's almost like the sketch is too small. I struggle to see it. Let's just make it bigger. Okay, yes, that's big enough. Okay, so just make sure that was PQ was 6 and OP was R. So basically this one will be R plus 6, and that's what I showed you there. So if I want the big one, the big sector, it's that, okay? It's almost like you can first do it like that, and then you subtract this again, but now you just work with the white sector, and then you must get an answer of 28. And now it's basically just simplified. Just remember, that this is two terms inside, so it's not just r squared plus 36. You have to find that middle term, you say r times 6 times 2. Okay, and then you do that one and you just simplify. It's just a lot of simplifying. So there's the pi, the pi's cancel out because pi is there, and I just press that in my calculator. Luckily that cancel also out. Do you see? And I end up with that, and I get the value of r is 4. Just going to make it a bit smaller. Okay, I want you to stop the video and I want you to do number 1. You can continue the video as soon as you are finished. The diagram shows a paper fan. The shaded part area is bounded by the lines AB and CD, yes, and the arcs AD. OA is that 5. AB is X, meaning this will be X plus 5. Okay, if the shaded area is 30, find the value of X. Okay, so let's just start with that one. So again, I'm starting by saying the shaded part, which is that green, this is number 1, is equal to the area of this big one, OBC, minus the smaller one, OAD. Okay, and now I'm just going to start by saying the shaded part is that 30 pi. The area of the bigger one is always that angle, 144, over 360. Multiply, okay, it's now the area of the circle, which is pi, multiply, but the big one is x plus 5 squared. Okay, it's not necessary, I think, to write this one. I'm going to take that away. Okay. So, minus, you can keep this in a bracket, but it's also not necessary. So again, it's that 144 over 360, multiply, and now this one is better, and because it's just going to be the short one, 5 squared. And I just simplify. So this is 30 pi equals that 144 over 360 multiplied pi now I'm just going to put this in bracket. Okay, so x times x is x squared plus x times 5 times 2 is 10x plus 25. Okay, there's the pi, minus, and then this one, I can simplify this. If I press on my calculator, I could have already simplified there also. 144, ABC 360, it's 2 over 5. So let's just do it here also. It's not necessary, but it will help. And this will now be 25 pi. Okay. And now it's almost like if I'm taking out now pi here, so let's just quickly see. If I'm going to say 30 pi is equal. Now if I take pi out here, so it's almost like I take pi and then it's bracket. Then it's 2 over 5, and don't forget that x squared plus 10x plus 25 minus that 2 over 5. Oh, you could have multiplied also in there. 2 over 5 multiplied 25 over 1. Okay, but all that I want to show, I'm going to divide by pi, and I'm going to divide by pi, so the pi's will cancel. So I'm ending up with 30 equals 2 over 5, 25 plus 10 pi plus x squared. This is 5, it goes in 1, 5, so minus 10. Okay, 25, 10x, x squared minus 10. And I'm just simplifying that now. So if I'm simplifying this, I'm just going to get 30 equals. So now, I just want to see where is my mistake here. Why did I make it a pi? It should have been an x. Okay, so if I simplify this, okay, I'm just going to simplify this. So it's 5, it's going to be 10. If I do this, just say 2 over 5 divide 10, so it's going to be 4x. I'm just multiplying it in. Plus that 2 over 5 x squared minus 10. I think I'm taking a long road. Okay, so basically, if I'm simplifying this, I get 30 equals 4x, because that 10's cancel out, plus 2 over 5x squared. Now, I don't want fractions, so how do I get rid of fractions? I put it over 1, and I times with 5. 5, 5, 5, 5. So I will end up by getting, okay, so let's just simplify this one then. So if I multiply with 5, just want to quickly see, 30 times 5, so it will be 150. I'll simplify now again. That will be 20x plus 2x squared. Okay, so I can divide 2, divide 2, divide 2, so I get, and 75 equals 10x plus x squared. And that will give me then, okay, if I'm just going to move it up a little bit, everything to one side, and just rearrange it as a quadratic equation. Okay, and that's in group B, do you see? So if it's in group B, you can say, let's take another color, 15 times 5, and 1 and 1. And the biggest overcross get plus and minus. So basically, it's going to be x plus 15, x minus 5. And then I will get x but this equals 0, so this will be negative 15, comping, or x is 5. Now, can distance be negative? No. So, therefore, x is equal to 5 centimeters. Okay, so you reject that negative value, and that's how you do it.